Hi, welcome to Cisco One. My name is Don Lafond, Professor Don, and I'm happy you're here. This week, I'm going to introduce um, in Module 1 networking today why we're here. Why are we in Cisco One? Why do we want to learn about routers and switches? I think it's going to be a very an informational PowerPoint in video. And I hope if you have any questions, please hold those questions until the end if you're live with me. If you are watching this as a recording, please ask your questions inside of the help discussion forum, or if I've posted it on YouTube, please ask your questions down below and I will do my best to answer those questions. All right, let me go ahead and share my screen. First thing I've got to do every time is I've got to let you see what I see. And then I need to move this over here. And I need to start the presentation. One second. I get a setup here. And I need to minimize this. All right, we are just about there. And we're ready to go. Okay, so Module 1, Networking Today. In today's presentation, we're going to talk about how networks affect our daily lives. We'll explain how host and network devices are used. We'll explain network representation and how they are used in network topologies, especially in this class where we'll use those network representations inside of our packet tracer to understand the difference between routers and switches and stuff like that. We'll compare characteristics of common types of networks. We'll explain how LANs and WANs interconnect the internet. It is the basis of the internet. It is what the internet is built on. We'll describe the 4 basic requirements of a reliable network. I'll explain how trends such as BYOD, online collaboration, video, and cloud computing are changing the way we interact. I'll identify some basic security threats and solutions for all networks. And I'll explain employment opportunities because, of course, you want to see what kind of jobs you can get in the field. 1.1, networks affect our lives, and they do. Communication is almost as important to us as our reliance on air, water, food, and shelter. Think about how we are connected today. In today's world, it's all based on networks. And I have a video to give you an example of that within the Cisco NetAcad Cisco. So give me a second while I pull up that video. And here is our video.
This is the world. Always moving, always changing. And nowhere is that more true than in technology. From the very start, we've been on a quest to make things easier, move faster, and expand our opportunities. And with each new innovation, the pace of change has only accelerated. To keep up, education has to advance and evolve as well. At Cisco Networking Academy, we believe that powerful learning comes from hands-on instruction with real equipment and software. So we're committed to giving our students a real-world grounding in today's most valuable skills. We've developed many of our own tools, including simulators that help them test their ideas at scale in different environments. And we keep it real by giving students the chance to test their skills in competitions and hackathons. They receive personalized feedback every step of the way, and not just from instructors. Automated, performance-based feedback is an integral part of the learning experience. Our classes are translated in up to 20 languages, making it easier to learn in your own language and share experiences with others around the world. More than technical skills, it's a broad-based program focused on creating global problem solvers, ready to move the world forward. Our students become T-shaped professionals, meaning they get deep technical knowledge in at least 1 or 2 high-demand job areas. But they also get the broader range of skills needed to collaborate across related technologies, which makes them even more valuable to potential employers. Preparing students to become the innovators of tomorrow, capable of successfully contributing to multidisciplinary teams that are setting the pace for the future of networking, the Internet of Things, security, programming, and information technology. They learn from the best trained instructors and earn certifications that can get them better jobs, higher pay, and a well-rounded career, meeting today's needs and tomorrow's opportunities. There's no saying where technology will take us next, only that the ones leading the way have the T-shaped skills you get at Cisco Networking Academy. It's how academies, educators, and students keep ahead of an ever-evolving world. Discover the latest courses and set out on an exciting career journey at netacad.com.
So hopefully the volume on that was good. I like playing the videos because the actual content makes a whole lot more sense when you see the videos that support the content. No boundaries. So we're talking about network. We're talking about a world without boundaries, global communities, and human networks. Every one of you could give me an example on how you've communicated with somebody in a different part of the world, or you have learned about something from a different part of the world. I remember the first time I Skyped a person that lived in South America. I could not believe that I was video talking to somebody in another country via this thing called the internet when the old phone. I remember AT&T when I had it as a child, and just calling somebody out of state was a horrible thing to do because it would cost 10 cents a minute, and my parents didn't want bills, right? So anyway, so today you don't have to worry about that. We'll learn about internet phones later, but it's all about networking without bounds. Components. So host roles. So every computer on the network is called a host or an end device. Servers, and that can be the PC that's in front of you, your cell phone, any connected device, a tablet that's connected to the internet, that is a host device. Servers are also host device. They're just fancy computers that serve email, web, file. Clients are computers that send requests to servers and receive information. A web page from a web server, for example, or email from an email server. So the client is asking for something from a server. Now, peer-to-peer, the client and the host, the client and the server can interchange. So this computer here this computer here could be serving the printer and but then be asking for information from the client, from the file sharing, right? Collecting a file, for example. So this device can be both the client and the server. The advantages of peer-to-peer: it's easier to set up, less complex, lower cost, and it's used for simple tasks like transferring files and sharing printers. Disadvantages is no central administration. After you pass around somewhere between 10 and 50 devices, depending on how much they're actually communicating, 10 heavy devices that communicate a lot will put a major demand on a peer-to-peer network. But if you got 50, like I have in my home, I have a peer-to-peer network like all of you do, and I have 50 IoT devices, including things like my smart light bulbs. I have at least 20 of those, maybe more. I have a smart doorbells, smart door locks. I have I'd love a smart toaster, and I have a smart washer. I'm sorry, a smart dryer. I don't have a smart washer because it hasn't died yet. As soon as it dies, I'm going to buy a smart washer. Anyway, so my devices are smart. It talks to me. My TV talks to me. So when my dryer ends, the message comes up on my TV and my phone saying that the dryer has finished. Now, I also have a smart car. That is the ultimate smart device. I have a Tesla Y, and I love that car. It not only keeps me safe when I'm driving down the road, but it also updates itself on the internet. And if I ever have a problem, I just talk to tech support on the phone, and they can tell me what's wrong with my car if there's any issues. Once my car wouldn't start, I called tech support. I said, it won't start. It won't start. They said, I don't know why it wouldn't start. Try it again. Start it right up. I swear, tech support on the other end flipped the switch someplace to get my car to run. I don't know, but I was happy it was running, and I haven't had that problem since. So anyways, I got a little sidetracked. We talk about that later. End devices are also called hosts, or where the messages originate and when they're received. So these are hosts. They're the end devices, and they use the inner work of routers and switches the inner network to talk to other end devices on hosts on other LAN. So this LAN communicates with this LAN with something called a WAN. We'll learn about that in a moment. Oh, we'll learn about that right now. Intermediate devices that inter-network is the intermediate device that interconnect the end devices. They include switches, wireless access points, routers, and firewalls. Management of data as it flows through a network is also the role of an intermediary device, including regenerating and retransmitting data signals. Maybe some of you have router repeaters in your home. That's kind of an example. Maintaining information about what pathway exists in the network, and then notifying other devices when you have an error. So for example, if you have OSPF, if that's what your network is using, and we'll learn about that in Cisco 3. But OSPF, the routers are always chattering to each other, telling them about all the networks they know. And then when there's a problem and a router goes down, the network can be reconfigured, and we'll see that in just a few slides. These are some of the end devices. The intermediary devices that we'll use, including routers, wireless routers. They have little antennas compared to a regular router. LAN switches, a multi-layer switch. A multi-layer switch is a router switch combination. It's a switch that can act like a router, and then they show you a firewall appliance, just showing you that there's other devices that would be used, obviously, for security purposes. To connect all these networks, you have to have some sort of medium. The medium can be copper, fiber, and wireless, and you spend a lot of time in your hardware class talking about these different types. Just know that when you're in network representation, this is what they look like. So this is wireless, this is a LAN medium, and then this is WAN. LAN is usually copper, and it connects devices like a router to a switch in a single cabinet, for example. But it can also be run from room to room inside of a building. People use copper because it's inexpensive and it's very flexible, so it's hard to damage that without literally cutting it. WAN media can also be copper, depending on the situation, but it can also be fiber connection between buildings, or even between regions, like different states or different countries. That's usually a very high-speed WAN connection. Topology. Now, when we're talking about topology, there's really two types of diagrams. There is the physical topology, and the physical topology actually shows you where things are. So in room 2158, I think that says, we have a web server on rack 2, shelf 1. We have the switch on rack 1, shelf 2, and it talks to the router on shelf, right? You see the physical location of all of the devices. There's also a logical device. It can be just as important. It tells you which port on the switch or the router or the server the device is connected to. So this device would definitely be helpful, say, when you're troubleshooting a device. This is helpful if you're going to look for some. So most environments have both a physical and a logical topology to help you navigate the equipment. Common types of networks. So I remember teaching this in the hardware class because I think it's actually pretty much the same slide. There are lots of different environments. So we can talk about a small home, that's you in your house with your mesh network. I have an AX ASUS mesh network with 4 nodes, and I have awesome connectivity now. It could be a Soho. This could be a small office, home office, and that is what this course is built upon. Maybe one router, one switch, or a couple switches, and maybe a dozen or less computers. Then there's a small, medium, or large. That's what Cisco 2 is built around. And that class, Cisco 2, teaches you how to connect networks more so than you do in this class. And then your Cisco 3 classes talks about how, what they call them autonomous zones, how wide area networks are connected to each other. Instead, these should be more LANs and short connected WANs. This is WANs, obviously, it's countries connecting, but those are called autonomous regions. And you learn all about that in Cisco 3 if you're here still at that point. LANs and WANs, it's a network infrastructure. Network infrastructure varies greatly depending on the size of the area that you're working, the number of users you have, the number and types of services available, and the area of responsibility. Two common types of networks include LANs and WANs. LAN, you've heard that term before, obviously, at this point. It stands for local area network. And right in it, it sounds like it's a smaller area, like your home, like your central office, like your branch office. And WAN is a connection connecting those different locations, whether different parts of the country or parts of a different state, or maybe just the college campuses. Now, the LANs and WANs, well, a LAN interconnects end devices in a limited area, administrated by a single organization or individual, and they provide high-speed bandwidth to internal devices. Now, WAN interconnects LANs. So here we have a LAN, and here we have a LAN, and here we have a LAN, and a WAN connects the two. Now, typically administrated by one or more service provider. That could be the ISP in the middle, or it could be a service provider for each, or it could be an administrator for each different LAN. So in a college, generally we have one administrator that handles the entire network, but we conceivably could have somebody in charge of the network on each campus, as long with somebody over all of the campuses. Hang on just a second. They say here that it typically can provide slower speed links between LANs, but we're really talking about the situation. So, for example, in a college campus connecting multiple buildings, you could have, it could be considered a WAN, and it would be copper. But if you're going between states, or you're going between, something in the a campus here in the U.S. and a campus in Europe, you are going to be on a high-speed connection under the ocean, a super high-speed connection. So WANs are not generally low speed, but they can be low speed, slower speed. All right. The internet. Now, the internet is just a connection or interconnection of LANs and WANs. You should know that. It's basically all these routers and switches in the middle, connecting all the routers that are at the end devices for all of the different industries and corporations and companies and every even your house, right? You connect to an ISP, but your ISP then connects to the world. So I want you to think, when you're thinking about why am I in Cisco 1, this slide really tells you why you're in Cisco 1, why you're looking to earn a CCNA. We all know the internet isn't going anywhere, right? We all know that every company needs somebody that can connect the computers together and then connect their business to the world, right? That's where your job comes into play. You will be the person that, depending on what level you're in, you will be the person that's making connections for your company to the world. You are the one configuring routers and switches, and the internet is just a connection of routers and switches and other intermediary devices. So that's why it's critical, why we need you, why you're in this class, why we need you in the program, why we need you to get a job and be smart and come up with even cooler things like that wireless toaster that I need, the wireless smart toaster that I need. We need you out there making sure that my toast doesn't get burned in the morning. Even my stove is connected, by the way, but not my toaster. I really want a toaster that's connected, but I haven't seen one yet. You can Google it and put it in the box if it exists, and I'll go buy one after class. Anyways, the internet actually isn't owned. Here in the U.S., we think we own it, and even Al Gore said the United States invented it, but no, the internet has been along for a very long time. TCP/IP has been around since the 50s, so the connecting devices together has been around for a very, very long time. The internet as we know it is probably not even 25, 30 years old. I remember sending my first or connecting to somebody for the very first time online in the late 80s. And I was amazed that I was talking to somebody live, and their first response when I called them using my computer, their first response was not, "This is so cool." Their first response was, "Don, do you know it's 2:30 in the morning?" It's like, "Oh, I'm so sorry, but isn't this cool?" It's like, "Call me back tomorrow." And that was my first connection from my standalone home computer to the world. I was so thrilled at the time. My friend wasn't so thrilled. Anyways, there are organizations that you're going to learn about in this class. You actually have an assignment near the end of the course where you will look up and do some research on about 10 of these groups that you learn that organize that manage the internet. Now, I want to talk to you about intranets, and I want to talk about intranets, and then the internet as a whole. So intranet, this is a company-only website. Usually you have to be on the campus itself to access the whatever it is. So for example, when I'm on my current campus, I have access to the shared drive for the department. But when I'm signing into the department from home, into my FSCJ, when I'm signing in, I don't have access to that. I have access to things like my financial records, and I have access to our classroom, and I have access to the courses that I may or may not be teaching next semester. But this extranet is for like salespeople to sign into the intranet, the internal organization that is then able to share the important information back to the extranet person, that salesperson or the teacher. Then there's the internet. That is the World Wide Web. Basically, you can get anywhere. You can do anything on the World Wide Web. Out here in the white, this is the dark web, even though it's white in my example here. That's where and this is also the dark web. It's places you can't get without knowing where you're going. The internet is where where if you Google something and you click on a link, you're on the internet. You know that. Routers and switches handle all three of these. Internet connections. They talk about DSL, cable, broadband, high speed, low speed. They even talk about satellite. They even, in one of these slides, they talk about dial-up. Here it is, dial-up telephone. You know, in some companies, dial-up telephone is actually still a backup in case the internet goes down, right? What does a company do if the internet goes down and all customer support is everything's through an internet? Well, a dial-up actually still exists. Some people still have dial-up, but I suspect, in addition to the dial-up, they probably have a high-speed connection. Otherwise, you're going to struggle because it's really low bandwidth, and you're going to have problems with things like watching videos and whatnot. Most people have cable, DSL, or satellite. I am one of the lucky people in the Jacksonville area. I'm lucky enough to have high-speed fiber to my house. It gives me 800. Somebody's having a problem staying connected. 800 megabytes per second. It really is that fast most of the time, unless there's some issue in the network. That's so much faster than what my DSL used to give me. I had DSL for like 10 years, and I was thrilled with 4 megabits. Now I'm at 800 megabits, and it cost me, I don't know, it's some stupid amount of money, like $49 or $50. I think it's $59. I used to work for America Online back when it was $29 for AOL. I worked for them. I took 30,000 tech support phone calls trying to help people stay connected with their dial-up phone. And I dreamt back then of having just a cable connection, never mind fiber to my house. But anyways, that's how we connect home and small offices. Businesses have dedicated lines, and that gives you guaranteed speed instead of just like your cable. If you still have cable connection to your internet, at 5 o'clock every day, you probably notice a slowdown in your internet because everybody in your local area is using the same cable connection. So everybody's using your bandwidth. But if you a business wouldn't deal with that, they wouldn't be willing to do that. So they buy a dedicated lease line, a T1, T3 annual. We don't spend time with that here, but I think you learned that in your hardware class. I'm pretty sure we learned about that someplace else. The converged network. Back in the day, the converged network, we had different people working on different networks. We had different cables running through the building. We had a line for the TV if you had a TV in your high school up in the corner. I remember that from when I was in high school. We had phones. They had their own phone line, right? Remember the 6-wire line, the smaller jack? I forget what that jack is. D9 maybe? Anyways, and then you had your high-speed connections. RJ11, thank you. I appreciate that. That's a great example of what I was hoping for from you guys, Peter. Thank you. Everything was separate, and it took different people that understood different networks. We had to pay different people. We had to run at the expense of running different lines. Today's converged network, we have data, voice, and video all on the same line. So if you have a TV up in the corner, like my wife, the administrator, they are putting a really high-end, fancy, large-screen TV in their conference center so that they can transmit either wirelessly or they can transmit wired to that TV for conferencing. And that's a fantastic idea, right? You get the TV, you can use it as a TV, you can have HDMI connections, my computer is connected wirelessly. It's also connected by a physical cable. So my TV is a high-speed connection that's always updating itself and talking to all the other devices in my house, like I was saying earlier. So that is happening in the workforce as well. We get one device that does multiple things. We have one cable going to a classroom, and that one cable might have multiple things connected to it, phones and computers and stuff. We're going to see a video. Oh, no, we're not going to watch the video about downloading and installing Packet Tracer because you can watch that on your own. And not all of you, most of you already have Packet Tracer installed. If you have a problem installing it on your computer, let me know or ask in the help discussion forum and we can help you get that installed and how to use it. When you have problems figuring it out, ask. We're here to help. Now, the next thing I want to talk about is there is a homework assignment. It's a Packet Tracer, and it will show you network representation where you are actually moving around some of those symbols I showed you before and connecting them with the cables. It's easy to do, and it will show you if you understand the basics of Packet Tracer. Okay. Reliability. Okay, reliable networks. Well, there's four. The architecture, network architecture, refers to the technologies that support the infrastructure that moves data across networks. There are four basic characteristics that underline that architecture, and they are fault tolerance, scalability, security, and quality of service. Altogether, they give you a reliable network. When you are working for a company, it is critical for you to understand not just scalability, not just quality of service, but it's really important for you to know the security, right? Somebody breaks into your system, you're in trouble. If you don't have a reliable network and it goes down because you don't have fault tolerance, you're in trouble. If you didn't think about the future and you didn't run the wires that you might need someday, then when you go to scale your system, you're not going to be able to do that. We cover them all individually. So fault tolerance limits the impact of a single failure, by limiting the number of affected devices. Multiple paths are required for fault tolerance. Reliable networks provide redundancy by implementing a packet-switched network. A packet-switched network splits traffic into packets that are routed over a network. Each packet could then theoretically take a different path to the destination. You've learned about packet switching when you learned about the internet as a whole. That's how the internet works. It's not possible with circuit switch networks. They establish a dedicated circuit. It's not exactly the same, but a good example of a circuit switched network that doesn't change is a VPN line. When you make a VPN connection, especially a secured one that maybe your office makes you use, that circuit switched network will remain the same, and packets will follow the same path from one place to another. Now, in this slide, they also show you that, let's say you have a router that goes down. If we're talking about fault tolerance, you have a backup router, so that router can then transfer information to the backup router, and then it can get to the internet. This network, as users, you will not even notice that there was a problem. You might get a glitch where something doesn't load, but generally speaking, you shouldn't even notice. The internet is that fast in today's world. Now, scalability is the ability to add on to a network. So at one of my campuses that I work at, I have, we just added a D building, or we added onto the D building a whole engineering building. It's connected by a breezeway. They still call it the D building, although it's not really connected except for that breezeway. I bet that has something to do with taxes or insurance or something. But anyway, so they're called the same building. And that new building, when they built the network, they had to think about, in the future, there may be additional buildings, additional programs that they add to the college, and we have to support it with additional resources like new buildings and new labs and new computers and new routers and switches to connect it all together. That's called scalability, the ability to take an existing network and then expand it to more devices. And then there's quality of service. When you talk about quality of service, we're really talking about the fact that video and phone service, for example, with our VoIP, it needs to have a higher quality of service, a higher connection rate and connection bandwidth than, say, surfing the web. Surfing the web or transferring a file via a transfer protocol, TCP. No, not TCP. Anyways, trivial. It doesn't matter. I'm missing that term. Anyways, you can put it in the thing. What's the term for I got DSL in my head right now, and I'm missing FTP. Thank you. So FTP, transferring a file via FTP or FTTP, you can those files can run slower. HTTP can run slower because those devices are going to not need, if you have to wait another second for your web page, not a big deal. But if you're talking to somebody on the phone and you lose the connection, you're not going to be happy. Or even if you have drops, or worse, if it were to play the missing piece later in a video or a phone call, that would be really confusing because it'd be talking and then you'd have a spot and you'd be talking and then it would come back from the past. So anyways, you need high quality of service. That's not taught in this class. The school we are in right now, this school actually has an entire course on voice over IP that I intend to take this fall because I want to learn more about it. But can you imagine just learning how to program the smartphones, right? You're not smartphones like this phone, but your voice over IP phones. Just configuring those takes an entire semester. I am baffled by how much focus is necessary for that one class. How can there possibly be that much information? Anyways, I'll let you know after I take it. Maybe I'll make some videos then too. Network security. Obviously, in today's world, I don't have to explain security. Just know that there's 3 goals. Confidentiality, meaning that only the intended recipient gets the data. Integrity, meaning that the data has not been altered by anybody during that transmission or by the person, anybody. And then availability. It's available on a timely and reliable basis. So those are your goals in network security. You don't want anybody to steal your work, whether they do it physically by literally going in and stealing a laptop over the counter, or going in and pouring water on your server or on your routers, or preventing access to devices themselves, either hardware or software. So you don't want somebody breaking into the network using sniffers and other devices. Trends, what's in our future? Well, recent trends is the role of BYOD, that's bring your own device, and online collaboration, like what we're doing right now. You can even consider what we're doing video communication, because we're using video to talk, and cloud computing. Video communication, it's more like talking. Like, I just did FaceTime for the very first time like a week ago. I've always been an Android person. I know you Apple people have had FaceTime for years, but I just figured out how to do FaceTime on my phone. Once somebody showed me how to do it, it's like, well, that's easy. But it wasn't easy on Android 10 years ago. At least I don't think it was. So that's more video communication. Online collaborations, what we're doing now. We're online. We're looking at a video. We're looking at a classroom. We're learning. We're talking. We're interacting with each other. That's really online collaboration. We actually talk about it here. Why do we want BYOD? They used to say, no, don't bring your equipment to work. Now, to the school. Now they don't do that because they save money by not having to provide as many computers. And if they don't have to provide as many computers for students, they don't have to update those computers every 3 years. You bring the device, it's your computer. You update your own computer. You put your own virus software on there. You put your own um, uh, um, uh, protections on there, password security, stuff like that. Now, the school, in my case, the school does have to be aware that you are putting devices on. So when I signed into the network for the very first time, into their Wi-Fi, they asked me to control my phone. They want to be able to wipe my phone if I lose my phone, and that's pretty scary. So you give them control in case something bad happens to your phone. They can help fix the problem, because they don't want maybe a virus on your computer to infiltrate their network. So anyways, BYOD is absolutely happening right now. Online collaboration, we're actually doing it. Right now we're doing a WebEx meeting, and I'll consider your team if you do. Video calls made to anyone regardless of where they are. It started with Skype, and now we have Telepresence. Basically, anybody working with anywhere, anyway, anywhere, anywhere, well, whatever. There's a video on that. Let me get to that video. Anywhere, in many ways. I think that's what I wanted to say. And here is our video.
You're gonna have to do that. Did you guys book this room? Because I'm pretty sure I booked this room.
All right, so some people said in the chat room that video didn't come through very good. So it could be an issue with my Wi-Fi connection, although I doubt it. It could be a connection, your Wi-Fi connection. But the ultimate solution for that, I will play the videos because I find them helpful, especially later in the semester when they're actually showing a concept. So you can always see the videos if you're in NetAcad by going to the index and then go into videos, and then you can watch the videos. You can start them on your own end and turn down the volume on my end, and you can see my volume, and you can see the exact same video. If you don't want to watch it while I'm watching it after the class, you can always go watch those videos. Sorry, if you're not actually in NetAcad right now and you're watching me on YouTube, then I'm not sure where you can go to see those same videos, but we'll keep going. So cloud computing. Now this is the big one. This is the big sexy word, cloud computing. And it's saving a lot of companies money because there's several different clouds. There are public clouds and private clouds, hybrid clouds, and custom clouds. You're going to learn about all of these cloud devices. Clouds, by the way, is just another word for somebody else's network. You are either uploading your applications to somebody else's network. You'll load, like OneDrive, you're uploading your personal files to some other network. If you are talking about, you can even upload the processing of data. You can use somebody else's equipment and their network of equipment. For a business, that can save a company a lot of money. Instead of buying a stack of routers and switches, they can just buy the access to routers and switches and servers on somebody else's network and pay a small price, which is awesome, especially if you don't know if you're going to survive, right? Will you ever get your money back for the investment in the hardware that you would have to invest in to get your company up and running? Just use somebody else's hardware and pay a monthly fee, and then ultimately, if you go out of business, you've only lost that monthly fee. You have not lost the actual cost of the equipment. Anyways, you can learn more about cloud computing online and in other classes, but they touch on it here because it is using other people's network. Literally, you are connecting to somebody else's hardware and software. Technology trends at home. I've told you enough about my smart home. I didn't see anybody say anything in the chat room about having smart light bulbs and Alexa or Google Home or any of the other devices. But I don't know, I think I even have 7 Alexa in my house. They're all over the place. She's smart enough now not to answer, but when I used to say her name, she would also answer. So in my previous videos, you would hear my Alexa answering questions. For some reason, she's being shy. Anyway, so everything is connected, and I love it. I absolutely love it. Now, they also talk about Powerline networking here. I'm not sure why they really throw this in here because it's really not applicable. It's basically a different way of running a connection. If we're not talking about wireless, we're talking about a fiber connection or a copper connection. This is a copper connection because what you're doing is you're putting 2 end devices on plugged in someplace, and then you run your your signal is transmitted over the copper wire of your house. It's being used for electricity, but electricity and wireless are completely 2 different things. Somebody in the class just told me that I changed the temperature in their house when I changed the temperature in my house. I apologize for that. Anyways, should be more cautious. Anyways, the cabling, just be aware that this number at the end, 400, actually means the speed of the connection. I thought it was just the model. And so I bought a relatively slow, inexpensive Powerline, and then I suffered with them until I realized that. Now I just have a Cat6 cable running 125 feet from one end of my house to the other to another mesh router, and it works fantastic. I don't use Powerline anymore, but it still exists, and I think they just want you to understand the concept. Wireless is what we all use, right? We use, well, you probably use, because most of us have a smartphone. We connect through the phone network, the cell network, but we also use wireless connections as well. You can have a wireless hotspot on your connection, or you can use somebody else's wireless connection. Maybe you bring a laptop to a local coffee shop and you're able to connect. Anyways, that is still growing. It's growing by leaps and bounds. It's unbelievable. It's all about 5G now. And I'm so glad when I bought my phone, I held out for the 5G, the true 5G, because it's unbelievably fast. And I'm happy about that. And it's going to get faster. You know, I'll bring it back here again. Actually, I bring it back here. They talk about cars with 5Gs. All the cars are going to have their own 5. My car has I don't know if it has a 5G connection, but my car will talk to other cars. So if a car is avoiding an accident, that car will talk to my car and tell me I'm avoiding an accident, move. You know, it's not relying on the driver. My car drives itself. So if a car tells it, hey, I'm coming into your lane, my car will look around using radar and say, okay, nobody to the left, I'll move into the other lane. And it'll do it automatically, right? That's what's coming. That's the future, the near future of wireless connection. Security. Security threats. We have to be aware of security threats, both physical and digital. We might protect from an external threat by using a firewall, or from an internal threat, people that actually do bad things to a computer. So this, you might have a bad actor here that gains access to your system, and now he's on your network and he's able to copy all of your personal information. I don't need to explain to you the security threats. You'll take a security class and you'll learn all about them. But every day in the news, we hear about somebody or a company, not somebody, but we hear about a company that has been hacked. And Facebook was one of the biggest ones recently. Every time I sign into some websites, it tells me that my password, 11 of my passwords have been hacked and I should change them. It's like, okay, I'll get around to that someday. Anyways, there are securities. You can make a living with network securities. You have to be aware of it at home in a small office. And then in larger networks, you have to be aware of it as well, because by setting access control lists and putting intrusion prevention systems in, which is hardware, generally setting up VPN connections to people that are away from the network, or even between campuses, like from North Campus to South Campus. You might have a VPN that might take all that information and make it safe. The IPT professional, that's why you're here. You want, that's right, recently the pipeline was hacked and now there's this massive gas crisis. Well, guess what? The world now knows that the United States infrastructure is hackable. So don't think that's going to be the last time that happens, right? And I heard the worst part is that the pipeline people, the people that own the pipeline, they paid $5 million to get their data back. Somebody wasn't doing their job. They needed backups, right? I also heard that they paid it early in the system, and it was just taking too long to get their backups up and running. So that is a failure of the network professional to protect from security, people outside the organization trying to do something bad. And it also hurt the financing of the company. I bet more than one person lost their job because they were not doing what they were supposed to do. They paid the $5 million. And the company, and they kind of know who it is that did it, some small organization in Russia. And the organization didn't say, yeah, we did it. The organization said, yeah, we're out to make money. And they just made $5 million. These are the certifications that you're going to get if you stick with this program long enough. Not just this program, but in the field. So you're going to get CCNA. You need to take 3 classes. You actually only need to take Cisco 1 and 2. You can teach yourself Cisco 3 and probably pass the exam. That's what I've been told. I had a student and the last 2 weeks of the semester take a Cisco 2 student take the class and pass it. And he said that he taught himself OSPF, and that's really what he needed to know for that Cisco 3. I know. Cisco 3 is a wonderful class, but Cisco 3 isn't in all of the programs that we teach. So a lot of people have to come out of pocket the $400+ that they have to pay to take that class, right? If it isn't in your program, you can't get financial aid to pay for it. So then you don't get the CCNA certification before you get out to the workforce. And I promise you, the CCNA certification will get you a job if you want to be in IT tech. Get the CCNA. If you can't take it for free, then if you can't take it because financial aid isn't paying for it, and you can't pay for it out of your pocket, you can learn it. Those guys that I told you on YouTube, go watch their Cisco 3 presentations, and you can learn the material that way, just as if I'm teaching it to you. You can also get all of the packet traces I told you. You can get them all on Dan's courses, so you can actually do all of the work on your own without taking the class. I know Cheryl wants everybody to take Cisco 3. What we really need to do is put Cisco 3 in more programs. If we can get Cisco 3 in more programs, then we'll have more students in Cisco 3, and then I'll get to teach it more. Well, I've never taught it because Cheryl won't let me, because she wants to always teach that one class that she teaches. But if we have 2 or 3, she promises that she'll let me teach one of them. Once you get the CCNA course, then there are specialist course. For example, like I was telling you earlier, IP phones is a specialist course. CCNA will get you a $50,000 job. Being a specialist, depending on the specialty and the need in your area, will get you $20,000 more. So this is a $70,000 job. CCNP, this is a $100,000 position, and CCIE, that's a above $100,000 job. So think 150 or higher, right? Here you are actually designing networks. You are actually the engineer designing the future of networking. Here you're the beginning tech. Here you're a specialist in one field, and there's several fields. Here you're a professional. You've been doing this for a while, and you're good at it, and you pass a certification to prove it. This is the DevNet program that I was telling you about. This is all of the programming in networking. And if I stay with this long enough, and I hope I do, I will start learning how to program networking devices, and I'll just bite the bullet and do it, even though I hate programming. I say that, but I actually applied for a job at FSCJ, and I was one of the final two. I was one of the 2 finalists in that position. They decided not to hire anybody in that position, but I made it all the way to the final interview for programming, and I don't even like doing it. So there's just a need, a real need for programming teachers. And if I get to DevNet and we start a DevNet program at the college, I guarantee that I'll be teaching those courses as well. Networking jobs. Find the jobs online. In NetAcad, there's a place to find them. And I went down to there's a link in the class that I'll share with you later in the semester, but it allows you to search for jobs. Here at the beginning, in this first week, you have to do a lab for an assignment to go out and find real networking jobs. And I tell you, there's a lot of them out there. It's not like computer teachers. I search for computer teachers on a regular basis. I don't find many jobs, but you look for networking jobs. As with a CCNA certification, I guarantee you will get a dozen or more, 50 if you broaden your range, 100 if you'll leave the state of Florida or move out of the state of city of Jacksonville, I should say. That is our presentation. So I really appreciate tonight. You guys have been fantastic. That is the first presentation in our course. We will be together for 15 weeks. I will make a video recording of every one of the PowerPoint presentations, and I will share that with you. So if you missed the presentation, you can always see it later. If you are here with me live, now I give you an opportunity for question and answer. If you are watching this as a recording inside of NetAcad with our current class, or if you are watching it as a recording on YouTube, ask the question inside the help discussion forum or in the comments below on YouTube, and I will be happy to answer those questions. At least I'll try. At least I'll point you in the right direction. Again, my name is Don Lafond. It's been a pleasure to be with you today. I look forward to the semester, and I'll see you again next week. Thank you very much for coming to class.